A particle starts from rest at the origin at t equals 0 seconds, and then moves in the positive x direction at a constant velocity of 24 meters per second for 1 second. At t equals 1 second, the particle starts to accelerate at minus 5 meters per second squared, so it's going in the negative x direction now. What is the particle's position when t equals 9 seconds? So to find that out, we simply just need to use this equation and then plug everything into this one. So for the first part, when it's not accelerating, the change in x is simply equal to the initial velocity times the time interval, since we do not have an acceleration. So it's just the initial velocity of 24 meters per second, and then times the time interval, which is 1 second, and then you get 24 meters. So that's the first part. Now the second part, it starts accelerating at minus 5 meters per second squared for the next 8 seconds. Since we're ending at 9 seconds, 1 second has already passed. So there's 8 seconds left. Now the first part was constant velocity, so its initial velocity is still 24 meters per second. And then this time the time interval is 8. Because we're going from 1 to 9 seconds, there's 8 seconds in between. And then, now remember this part is negative. So instead of adding this, we have to subtract 1/2 times the acceleration, which is 5 meters per second squared. The negative just went to the front. And then the time interval squared, which is 8 squared. Now you should get just 24 times 8 minus 2.5 times 64. Now if you do the math, this will simply be 32 meters. This will be more displacement in the positive direction. And then now to find the particle's position, we just simply add these two values together. So 24 plus 32, and you should get 56 meters. And that is the particle's position when t equals 9 seconds.